One of the key features of UltraMap is our water handling approach. Bernhard, why is it even important to have a water handling strategy in the first place?
Yeah, water can be very challenging in the photogrammetric workflow. Water bodies can have very different colors and very different texture, and there can be reflections from the sun. So water can be an issue for creating orthomosaics. It can be very difficult to create a good surface model or terrain model including water bodies, because with just doing dense image matching there would be a lot of artifacts on the surface of the water. And third, if water bodies are included in the data, then this can increase dramatically the processing time, because on the water surface matches in between adjacent images are not that easy to do, so the software has to search a long time, therefore very high consumption of processing time.
And we found a way to speed that up. What is our approach? How do we handle water?
Yeah, we have invested a lot of development resources into finding a workflow that is really optimized for high throughput, high automation, but still maintains the good quality. So our approach is based on machine learning. So we do first a semantic image segmentation to identify all the water bodies. And this semantic image segmentation is taking benefit of our Vexcel data program. So we have a huge library of image data from all over the world with very, very different water bodies. All that was used to train the software to make sure that we can identify the water with very high reliability.
And where do customers find our water handling strategy within the workflow?
So within the workflow, we recommend that this is done right after the aerotriangulation step, because best possible exterior orientation for the images is then the best input for the water handling. So water handling itself, it involves processing a low-res DSM, then doing the semantic image segmentation, and doing then deriving of height of water bodies, and later on moving on in the workflow. So following after that is then color balancing, then dense image matching, auto production, and so on. And in all of these steps, results and knowledge from this initial water handling stage is used.
So that's a great advantage for customers using the entire workflow. Could you show us something in UltraMap directly?
Sure. I'm happy to show you that with a brief overview. As our sample data for the Merlin 5 does not really include any big water bodies, I've prepared here a small data set captured with an Osprey 4.2 at the coast of Spain. So this is a data set that includes nadir and oblique images, and with this data set we can show nicely the workflow for the handling of the water bodies. The first step in this workflow is that a low-resolution DSM and a low-resolution ortho are created along with this water mask. So here in this DSM we still see all these artifacts from dense image matching, as the water bodies were not yet handled automatically here. So this is the first processing step where the user can already interact with the data, modifying the water mask, or the user could also bring in a water mask from an external source. Then in the next processing step, the software is automatically analyzing the height values at the coastline of the water, and then based on these height values it is automatically deriving the height of the water body. So here we see the water that is already very flat, with this height for the water being derived automatically by the software. That can also be loaded into the editor to facilitate then quality control of this, and also modification of the height of water bodies if needed. So here in this corner we see that the water is a bit too low, and that can be modified in a quite easy way. So now the operator is looking for height values here along this beach. So these are height values that can be used to do the new water body height. And with this tool here, this value of 1.2 meter, which should be used for the water body, can be entered, and then the tool can be used to create a polygon, and all the water within this data set gets now this new value for the height of the water. So this polygon that is created by the user is intersected automatically with the water mask. So therefore, at the coastline, the user does not need to do a lot of clicks to describe the water body in an exact way. So now switching in between results of before and after, we see that after the edit, it's a very nicely adjusted water body. And also in the main view, we see now the data corrected.